Hello everyone. In today's video, we will understand a very important concept in reliability, that is MTBF. What is this MTBF? Why is it important? What are the common misconceptions regarding MTBF? And some practical examples, all from a reliability engineer's perspective. Now, MTBF stands for mean time between failures. It is a reliability metric for electronic or electrical components. Before going into the formal definition of MTBF, let us understand it with a practical example that we are all familiar with, a laptop. To estimate MTBF of a laptop or any product, we need its failure history. By that I mean what is the time of failure of that product and how did it fail, that is what is its failure mode. While MTBF considers all failure modes in its estimation, we can also estimate MTBF for a particular failure mode also if its probability of occurrence is high. In this example, I have considered 4 failure modes. There could be many more. So as we see in the table, the first failure mode is the touchscreen failure. So starting with a healthy laptop at time t equal to 0, the failure time observed is 2 months. Therefore, the time between failure TBF is also 2 months. Now, laptop is a repairable system, so we got it repaired and functional. The next failure mode observed is the battery failure after an operation of about 1 year, that is 12 months. Time between failure is the time difference between two consecutive failures, that is 12 months and 2 months. So we get the time between failure of 10 months. Now we got it repaired again. The third failure mode encountered is the power supply circuit failure. Similarly, for this we got TBF of 12 months. Got it repaired again. And lastly, we encountered the motherboard failure after 4 years of operation. And we get the time between failure of 24 months. So taking the 4 sample points from the previous table, we estimate MTBF of the laptop to be 12 months. Now we can formally define MTBF. It is the mean of the product operating time between two consecutive failures. In reality, however, MTBF comes from a large database of failures like Mill Handbook 217F, which is a prediction methodology. Now the sample MTBF, that is of 12 months we just discussed, is not the exact figure of the laptop MTBF. To get a realistic value of MTBF, one needs data from a large sample size of laptops. Laptops belonging to different vendors and laptops over a large operating time. And finally, MTBF is contributed by different failure modes as we saw in the earlier example. Now, what are some common misconceptions of MTBF? People generally think that MTBF and MTTF are same or can be interchangeably used. But that is not true. MTBF is applicable to repairable systems, while MTTF, which is mean time to failure, is applied for non-repairable systems, like your mobile chargers. Saying MTBF of a product is 5 years is incorrect. The right way of saying is MTBF of a product is 5 years at 25 degrees Celsius. Always specify the environment. And finally, which is the most important misconception, is that MTBF is the life of a component. That is not true. It is actually a population attribute and not the life of an individual component. Now, individual life could be 2 months, just a day, or even 2 years. But MTBF does not convey anything about the life of a component. So what is the real significance of MTBF? MTBF can be used for reliability prediction at component, PCB or system level. Let us understand this with an example. Assuming exponential distribution for electronic components, which is normally the assumption, and taking the MTBF of 10 years, lambda, that is the failure rate of the component, is calculated from the inverse of MTBF, which comes out to be 0.1 per year. The reliability expression is equal to e to the power minus lambda t. Now substituting the values of failure rate, that is lambda, and time t equal to 2 years, the reliability of the component is estimated to be 0.135. That is, if the MTBF of a component is 10 years, then after a period of 2 years, the probability of survival of that component is only 0.135. This is the actual meaning that MTBF gives us about reliability. Now, industries use MTBF to estimate spare parts needed. MTBF can also be used for comparison between designs. Suppose we have two designs. Design A has MTBF of 5 years and design B has MTBF of 10 years. So naturally choose design B. While MTBF in no way tells you the guaranteed lifetime of a component. Now let us see some examples for MTBF. Here I have taken the example of a Gaia make DC-DC converter with the MGDM04 series. This data of MTBF is from its data sheet. Now the manufacturer is giving us MTBF value according to mill handbook 217F. Now this standard mill handbook talks about different environmental conditions like shown here: ground fixed, airborne, inhabited, cargo, depending on where this component will be used in which kind of environment. Now MTBF has been estimated for different temperatures, as you can see. This is the case temperature of the DC-DC converter. We have MTBF values at 40 degrees, which is coming around to be 16,50,000 hours. Now, if we increase the case temperature to 85 degrees, the MTBF has reduced to about 6,45,000 hours. Now, we change the environment. We go for airborne, inhabited, cargo. We get much lesser values of MTBF as shown here because this AIC environment is a much harsher environment. Now, Mill Handbook 217F is one of the methodologies to calculate MTBF. It is a reliability prediction standard for electronic or electrical components suitable for defense, aerospace, and nuclear applications. If you want to understand more about this standard, leave a comment in the comment section. Secondly, we look at the industrial AC-DC power supply example with its data sheet here. This is the reliability data offered by the vendor. Now he says MTBF minimum at 230 volt AC, 3 kilowatt power and operating temperature of 25 degrees Celsius. This power supply module has an MTBF value of 500,000 hours based on Telcordia SR332. And the operating life of this power supply at the same conditions is 26,280 hours. Now you can see the difference between the operating life of this power supply and its MTBF. MTBF should be used to get statistics of reliability, while operating life tells you about the actual life which has been obtained from experiments. Telcordia SR332 is another prediction standard to calculate MTBF. It is suitable for commercial and telecom equipment. If you have liked my video, like, comment and subscribe to my channel for more videos in this series, and let me know what topics you would like me to teach in the future. Thank you.